Hi everyone, I'm Priyadarshini Senthilkumar, Technical Marketing Engineer from the Switching TME team. And in today's session, I'll be covering Symmetric IRB on AOS-CX Simulator as a part of the 10.13 update. So here's the usual agenda for the call. I'll go through the feature overview, its use cases details, the configuration details on my CX simulators, along with a little bit of troubleshooting commands and a quick demo. We'll also have a look at the caveats and the additional resources. So let's jump into the overview. So before talking about the AOS-CX simulators, we should talk about what was the existing capability before the 10.13 release. So in the CX simulator, before 10.13, only L2 VXLAN was supported. So that traffic was enabled only across the same VLANs. So what is Symmetric IRB? So Symmetric IRB is Symmetric Integrated Routing and Bridging, which seamlessly combines both routing and bridging functionalities within a network and enables routing for traffic between different VLANs I have highlighted here. So the primary goal is to allow the devices in different subnets or VLANs to communicate with each other efficiently. So Symmetric IRB works both on the entrance and the exit, that is the ingress and the egress sides of the network, to ensure that the data packets get where they actually need to go to. And in the same way, VTEPs in the network don't have to hold unnecessary ARPs or MAC addresses. And VTEPs only try to keep the addresses they need for efficient communication. So in Symmetric IRB, when the data is sent from the source VTEP to the destination VTEP, it is not necessary to specify the destination VLAN or VNI on the source side. So the symmetric network infrastructure itself takes care of this automatically. So these are some highlighted overviews of what symmetric IRB is, and we will discuss about how this is implemented using Aruba AOS-CX simulator. So in the 10.13 release, a major update is that in the CX simulators, L3 VNI is used and symmetric IRB is supported. So before this, only centralized gateway and centralized gateway and asymmetric IRB was supported. From 10.13, symmetric IRB will be supported in the AOS-CX switch simulators. And in this case, we'll be using L3 VNIs. So in the context of symmetric IRB, L3 VNI suggests that this virtual network identifier is associated with the layer 3 routing. And the association of L3 with the VRF means that you can apply this layer 3 routing capability to different VRF instances. So here I have a VRF called VRF1. And this is particularly useful in scenarios where you want to maintain the network segmentation and security. So distributed L3 gateways can be deployed across the overlay network to optimize both L2 and L3 network connectivity. So how will this help us? So the significance of the symmetric IRB on the simulator will help us to mimic the complex network environments and to make it a valuable resource for testing more versatile and integrated network configurations. So this will be the topology that I'll be using going forward throughout the session to refer to, and how it is and how it will work on the simulators. So let's jump into the use cases. So two main use cases for the CX switch simulators are, the first one being that it serves as a valuable tool for a variety of use cases, making it easier to learn, test, and troubleshoot network configurations without the need for physical hardware. So for example, this topology would require at least 5 switches. So our CX simulator eliminates the need for so much hardware, and it can also be used to replicate problems and test potential solutions to gain a better understanding of how to resolve issues on real switches. So here I've just given a screenshot of one of my spine switches, spine A, of how it is deployed in my vSphere environment. So I have deployed my entire, I have deployed this entire network in my vSphere environment. I have 2 spines in my network along with 3 leaf switches, also called the VTEPs, VTEP1, VTEP2, and VTEP3. And this is the spine A and spine B. And hosts 1, 2, and 3 are attached to all the 3 VTIPs. Let's look at the details and caveats. So the Symmetric IRB on the CX simulator supports both IPv4 and IPv6 on distributed gateways. And one important thing to note here is that default VRFs cannot be attached to a L3 VNI. So it always has to be a user created VRF. So here I am using VRF1 that is attached to my L3 VNI. And to my L2 VNI, I'll be attaching the corresponding VLANs that I'll be creating on each of the VTIPs. So the active gateway MACs should be same across all the VTIPs in the CX simulators. This is not the case in the hardware switches, but for the CX simulators, this is one important detail to note. So generally, for the symmetric IRB configurations on the hardware switches, we use this command called virtual MAC, but this is not required on the CX simulators. This setup will still work without a virtual MAC across all the 3 VTIP switches. And the CPU generated traffic does not get encapsulated in symmetric IRB on the simulators. So a point to note here is that since the CPU traffic is not encapsulated, we will not be able to ping the gateways of the VTIP1, VTIP2, or VTIP3 from any of these 3 switches. So for example, ping from VTIP1 to gateway of VTIP2 or ping from host 1 to gateway of VTIP2 fails in this scenario since the ping packets here are CPU generated. So let's move on to the configuration. So referencing this topology, I will go through the configuration on each and every switch CX simulator, and here I have the spine A configuration. So my spine A is configured for OSPF on the downlinks to the OVA leaf VTEPs here. And IPv4 BGP EVPN is established between the VTEPs and the RRs, that is the route reflectors. And this, which has been mentioned here. So I have a peer group called leaf where all 3 VTIPs are listed. So the first leaf is 192.168.1.3, the second is 1.4 and 1.5. So it designates the leaf peer group members as the route reflector clients of the spine, which means that these neighbors will receive route updates from the route reflectors in the BGP network. And apart from that, under the address family L2 VP and EVPN, I'm also specifying the neighbors that needs to be activated. So again, for my spine B, a similar kind of configuration along with my OSPF, area 0, and then BGP 6501 is followed, with the neighbors 1.3, 1.4, and 1.5 under the peer group leaf being activated. I have VLAN 10 on these 2 VTIPs and VLAN 12 on this VTIP just to show the cross functionality between the VLANs. Moving on to leaf 1 here, which is 192.168.1.3. So here, one important thing to note is that I have the interface VXLAN1 command enabled, so which will facilitate our L2 and L3 VNI tunnels. So here we do an L3 EVP and VLAN mapping, and we are redistributing the host routes. And VTIPs will advertise the client IP within the fabric VTIPs. Corresponding VNI and VLAN mapping is done here. And under the BGP context, the BGP neighbor relationship with the IP addresses of 192.168.1.1, which is my spine A, as well as 192.168.1.2, which is my spine 2, associates it with a peer group called spine RR. So previously we had the peer group leaf, and this is the spine RR peer group. So we are also attaching that to our neighbor leaves. So this command activates the BGP neighbor with the spine route reflectors and sets up neighbors to exchange EVPN information for the VRF1. Correspondingly, in leaf 2, we have the similar VNI mapping for VLAN 10 and VRF mapping for this particular VNI for routing. So this is for switching and this is for routing. And BGP neighbor relationship is established between them, thus activating the BGP neighbor with the spine route reflectors as done in leaf 2 as well. And Under the VRF context, the host route is established for both IPv4 and IPv6. As I had highlighted earlier, we'll be testing this for both IPv4 and IPv6 across all the CX simulators. And this is the configuration in my leaf 3. I've again repeated the same configurations with respect to OSPF BGP, and the corresponding L3 VNI mapping is done with the VRF1. So let's move on to troubleshooting. So a few basic troubleshooting commands that help me test my setup are listed here. So I use the show command show BGP L2 VPN EVPN to check my EVPN route entries, which are listed here, and including the MAC addresses that are mapped to the corresponding IP addresses of both IPv4 and IPv6, and corresponding VXLAN tunnel information as well. So this also gives us information about the route distinguisher and the route target information for the EVPN routes. So I have used two other show commands, the show EVPN VTEP neighbor, all VRFs, in order to view my VRF information specific to particular VNI. And to view the detailed information for all EVPN instances, I have used the show command show EVPN EVI detail. So the output of this command helps us monitor and troubleshoot the VTEP neighbor relationship and their associations with the VRF instances. And it is a valuable tool for verifying the configuration and status of the EVPN instances. So another command that really helped me was the show ARP all command, and it gives us information about the ARP entries, including the IP address it is mapped to, along with the MAC address, port, and state. So I have captured the output for both my leaf 1 and leaf 2 here. So let's look at a quick demo. And in the demo, we'll be trying to ping between hosts of the same subnet, and we'll also try to reach the host of different subnets. So I have VLAN 10 here and VLAN 12 here. We'll try to ping from VLAN 10 to VLAN 10 first, and again from VLAN 10 to VLAN 12 to see both L2 and L3 can coexist on the CX simulator setup. So here I have 3 Windows clients, and this is my OVA. So here I have 3 Windows clients, Windows Client 1, Windows Client 2, and Windows Client 3. So I just did a quick IP config on this to show my IPv4 address, IPv6 address, and IPv4 address configured here. So the host address for this is 10.1.10.3, and for my client 2, the IPv4 address is 10.1.10.4, and IPv6 corresponding is 10.10.5. And for my client 3, I have 10.1.12.5 and corresponding IPv6 address, which are on different subnets. So let's try to ping from client A to client 3. We can see that the L3 tunnel is established and we are receiving the response. We will also try to ping the IPv6 address of client 3, which is 2008.12. So we can see that the L3 tunnel is established, it is up and running from host 1 to host 3. Similarly, I'll try to reach my host 2 from host 1. So my host 2's IP address is 10.1.10.4. So L2 tunnel is established, up and running, and we can see that both L2 and L3 are coexisting on the CX simulator setup. And my IPv6 address is 10.10.5 here. Let me try to ping that as well. So that is also reachable. So let's go back to the slides. And that's pretty much it with respect to the Symmetric IRB on AOS-CX simulators. And for further questions, please reach out to this PDL.